When you're writing code, are you doing it right? That's the question that worries a lot of people, and it should probably be at least something you think about. Design patterns are best practice concepts that we can implement into our code to make it better in some way. Think of them as guardrails to keep our code safe. In today's video, we're going to be looking at the third entry in the famous SOLID principle. The L stands for the Liskov substitution principle. We're going to dive into what that means, how it should change our programming practices, and how far we should take it. For those of you who don't know me, my name is Tim Corey, and it's my goal to clear up the confusion and frustration around learning C#, because learning software development shouldn't be so hard. If that sounds like something that would interest you, I think you'd benefit from subscribing to my channel and also from joining my mailing list. The mailing list is where you're going to get exclusive content and insider access. You can find a link to join the mailing list in the description below. So let's start the conversation on the Liskov substitution principle, which we're going to call LSP from now on, by looking at some code. I could do a nifty PowerPoint for you and show you fun pictures, but I think it's best to show it in a practical manner. So here I have a project that I've created in Visual Studio in C#. Now the principles of this video actually apply to any software development language, but since this channel focuses primarily on C#, that's the language we'll use. The code I have here is rather simple. I have a console application right here that demonstrates the use of creating different employees. So I have right here the creation of a simple employee. Let's call him Tim Corey. Here I have the creation of a manager, which is a type of employee. And then down here I have the class library, which actually has 3 different types of employees. We have a standard employee, which the employee has a first name, a last name, a manager, a salary, and then a couple of methods here, assign manager and calculate per hour rate. Then we have the manager, which inherits from employee and overrides the calculate per hour rate, and also has this additional method, generate performance review. Then finally, the CEO also inherits from employee. It has the overridden calculate per hour rate. It also has the assign manager overridden, but it just throws an invalid exception because the CEO has no manager. And then it has also the generate performance reviews and the fire someone method. All right, so that's the basic overview of our little program right here. Now, the problem with this program is it actually violates LSP. So now that we have some code in front of us, let's talk about LSP. LSP states, and this is the definition, if S is a subtype of T, then objects of type T may be replaced with objects of type S without breaking the program. So that's the really simple definition, which, if you think that's simple, you should read the larger expanded versions, because they use fun words like covariance and contravariance, preconditions, postconditions, invariance. There's a lot of big words there. But let me see if I can break all this down for you by illustrating what the rule is really saying. Here's the very, very basics of it. Here I have an employee, the base type employee, just call employee, that I'm creating, and I'm doing some things with that employee. LSP says I should be able to use manager here without breaking anything here. Now, and here's one of the key things here. Yes, this calculate per hour rate will be different in how it calculates the rate. That's okay. But what it can't do is it can't throw an exception where the employee would not have. So for example, let's put it back to employee. I'm going to run this application just to show you that it does work. And all it does is it creates the employee and the manager. And at the end, it says the employee's first name, so that's Tim. Tim's salary is, and then it gives me my salary, $16.50 an hour. If I were to change that and put in manager, because manager is a subtype of employee, I should be able to replace employee with manager. If I run this again, it works. And now it just says Tim's salary is $27.75 an hour. So that worked. And you think, great. Well, let's do it one more time, but this time, let's say CEO. I run this, and it throws this exception. The CEO has no manager. So let's stop and look. Here, I was assigning a manager to this employee. Well, because I made them a CEO, I can't assign a manager. Therefore, it blows up. And that's what LSP is saying is a problem. It's saying if you have a child type or inherited type, like manager, which inherits from employee, or in this case, our issue was CEO, this CEO should be able to be put in place of wherever you see employee and not break the application. And it did. It broke the application because a CEO has no manager. So that's our problem. So that's the very, very basics, but at the same time, that's the whole point of LSP. Now, let me just touch for a minute briefly on a couple of things. The covariance and contravariance. You'll hear those words thrown around. So the covariance talks about the return type of a method. So it's saying if you have a return type, that return type can't change, which that's really hard to do in C# anyways, if you're inheriting. So right now, these don't have return types. But what if I said, you know what, for manager, I actually want to return that value as well. So I return a decimal. Well, that won't work like that. That wouldn't really work because it's not matching up with what it's overriding, that calculate per hour rate. Okay. Now there is a way of doing it with interfaces. So I'm not going to say it can't be done in C#, it can be, but it's really hard. And quite frankly, you probably won't get into this. Okay. But just know that when you see that, when you see them say something about covariance, it's just talking about changing that return type. And contravariance just talks about the input type. So if I change this int to a double, say, that you can't do either. But again, you'd have to have some kind of interface in order to get that to work the way you're intending. So just know that those big words out there, we're kind of already covered for those. All right? And the other thing is we can't have preconditions and postconditions. So it's saying for preconditions, you cannot strengthen them. Okay, what that just means is let me just point out a method here. We have this method, calculate per hour rate. And this is an employee class. And it takes in a rank. Right now, it does no check on this int to make sure it is a positive number, to make sure it's within a range, any of that stuff. If in the manager, for this calculate hours rate, if I said something like, if rank is less than 0 or rank is greater than 5, throw new, let's say exception, whatever. You can't do that, okay? Because what would happen is it would work for employee, but when I replaced manager and put that in the place of employee, it might break. And so you can't strengthen preconditions. And also you cannot weaken postconditions, meaning you cannot be really strict on what comes back here. So if we say, if this were returning a value, if we say what has to return a value inside this range, well, you can't weaken that then for the child item. So big words that don't really apply in about 99% of cases, especially in C#. But just know that they're out there, and those are kind of expanded on the rules. But basically, what it all comes back to is the idea that you can't change how this functions radically. Okay, you can't make big changes to how this base class works. And one of those changes that we're going to get into is this one right here, where you have the assign manager. One of the kind of sub rules or interpretations or expanded version of the LSP says you cannot return new exceptions. Well, this right here is a new exception. Okay, so that is something unexpected that wasn't returned by the original assign manager method. And the reason why we can't return new exceptions, which we can't even do it in other methods, like if we have an if statement that says, well, again, if rank is, actually in manager, if we said if rank was less than 0, then throw an exception, we can't do that. The reason why is because if we're not looking to catch those exceptions then on the employee, then if manager or CEO throws that exception, it'll be an unhandled exception. And so it's going to crash our application in an unexpected manner. And that's really what we're talking about, is unexpected behavior. So if employee is expected to work in one way and CEO works in a different way, that's a problem. And this really comes down to a correct view on inheritance. And this is where a lot of times what I do is I gravitate more towards an interface rather than inheritance. Now, you can still have, to an extent, LSP applying to interfaces, but it's really, it doesn't. Almost. But with inheritance, the problem is that it's very easy to get tripped up. Okay? We say with inheritance, you have to have an is-a relationship. So a manager is a employee. Okay? And you'd say, well, a CEO is a employee. Yes and no, and actually no. And the reason why is because we're not just saying in the abstract sense, we're saying based upon the information that we've assigned to the employee class. So one of those is that we assign them a manager, and they have this property called manager. Well, guess what? A CEO is not a person who has a manager. Therefore, the CEO actually fails the is-a relationship. Because they don't have a manager, they wouldn't be assigned a manager. And so that's where it really comes down to, is LSP is just kind of putting a flashlight on our inheritance structure and saying, this is how you tell that you're doing something wrong. It's saying, look at this from the perspective of true inheritance and say, is this really true? And it's not. And so really what should happen is we need to change our structure. So we'll get to that in a minute. We'll work through how to redo this so that we still have some inheritance or some shared code base, but at the same time we don't have this idea of inherit everything, even the incorrect things, like this assign manager. But I think this is also a good time to talk about our previous lesson, which was on OCP, or open close principle. And let's look at the employee class. So I have this base class called employee, and I have some stuff in here, and I want other classes to inherit from this to get the shared code base, which is great. But here's where the tricky part comes in. In order for me to override the, say, assign manager class or the calculate per hour rate, I have to make the method virtual. So if I am going to down the road create a new class, let's call that class janitor. For whatever reason, janitor gets their own class that's a employee, but maybe we want to add a property, a list of string called keys, and it lists all the different keys they have for the building. That's great, but what if I want to, in the janitor, override something else? Well, I have to make sure that item is marked virtual. So I have to, when I create this employee class, think through anything that could be overridden and make sure I mark it as virtual, because otherwise I'd have to come in here and modify this base class in order to add my new class, which would violate the OCP principle, the open-close principle. So that's a problem. So just make sure that when you're thinking this thing through, that if you do want to do inheritance, and that does make sense for the situation, that you think through down the road how it might be used and make sure you apply virtual where it's important. Because otherwise, your callers or your children of that class won't be able to override a particular method, in which case they're locked into doing it the same way that you're doing it. Either that, or they're violating OCP by going in and changing your base class. So just something to think through. We're kind of building on each other here. So this isn't saying, and this is one of those things you get careful on, this is not saying never use inheritance. Because it kind of feels that way sometimes, because you're like, oh man, there's so many limitations, I just won't use it. That's not the answer. But what it is hopefully going to do is discourage you from using inheritance in the wrong way. It should be clear that yes, this is an inheritance situation. This is truly a case of the child is a parent class. So like a manager truly is a employee. So that's hopefully what we're going to get to in this LSP principle, is that we actually think through that process and make sure we lock in, yes, I'm going to do it for the right reasons, and I've thought through these things, because if it violates the LSP, then it shouldn't be done. So let's talk through, how do we solve this issue? How do we resolve this so it still has inheritance, but at the same time is compliant with LSP? The first thing I'll point out is there are some things that are common with employees, managers, and the CEO. Their first and last name, they all have it. They all have a salary. And we can calculate the per hour rate for each one of them. So those are all things we have in common. What we don't have in common is this manager line, the assigned manager, and then also notice the manager class and CEO class both have this generate performance reviews. Okay? So that's an extra method, which by the way, with inheritance, this is fine. And this does not violate LSP at all. Because they have an extra method, it's not in employee. So if we swap out employee with CEO or manager, that's fine. They'll never even know about the fact that we have this extra method called generate performance review. So it's not going to break anything. So instead, we can actually make this a little better as well. But let's start with the employee class. Now there is a shortcut we can do if you already have a class and you want to create an interface, which is what I want to do. If you, on the class itself, select it, there's a little light bulb to the left, or Control Dot will pull the menu down. If you drop down this menu, one of the options in here is Extract Interface. This is really convenient. So I'm going to create a iEmployee interface, and we'll leave it in the same spot. Notice I get to choose which items to bring along. Well, I want to bring first and last name for sure, not manager, but salary. Yes, to calculate per hour rate, but not to assign manager. I hit OK, and there's my interface. Done. It's great. So my interface being done, actually go back to employee, notice I now implement the iEmployee interface. And that's cool. So now what I can do is I can go back and actually create another interface. So let's right click on my demo library and add new item, interface. I'm going to call this the iManager interface. And I'll make it public. And this is actually going to inherit from the iEmployee interface. So an iManager is an iEmployee. Now a manager, what they have access to is one more method, which is generate performance review. I'll actually copy the signature here. Okay, so now we have everything employee does plus this generate performance review. And create one more interface, right click, add new item, interface, iManaged. Now I debated on this title. I also thought, I am peon or I have boss or something like that, but iManaged seemed like it worked. So iManaged, and that also inherits from iEmployee. And with this one, what we're going to do is go back to our employee class and grab both the manager. So I'll grab that. And then also we're going to come back to the employee class and grab the assign manager. Oops. There we go. And what I'm going to do here is I'm going to change this to iEmployee instead of the employee. And also the iEmployee manager right there. Okay, so there we go. So now we have three interfaces. We have the employee interface, which is the base interface, which has just the stuff in common with everything. Then we have the iManager interface, which has that additional method. We have the iManaged interface, which has the manager property and also the assign manager method. Okay, so now we can come back here and change up how our system works. So instead of the manager inheriting from employee, we could change it so they can implement the iManager manager interface. The only problem is that we no longer bring in all that code, which isn't a ton. We have, we're pretending it's a ton, all that code from employee. So we have to implement the first name, last name, the salary, and the calculate per hour rate. So, which is not great. We've lost quite a bit here by doing that. So instead, we've got to make one more tweak. So what we're going to do is right click on demo library and add a new class. We're going to call this class, let's call it base employee. There's probably a better name for this, but base employee works. And this will be of type iEmployee. So now on the employee class, let's go ahead and find that again. Let's fall off the screen here. I'm just going to copy and paste this whole thing for right now. But we're going to take out the manager and assign manager. And we'll have just these right here. In fact, I may even make this so that you have to override it. I may make it abstract. I probably won't. I'll leave it this way and just say we have the base employee has this calculate hours or per hour rate. So there's a debate here because this changes in every one of our classes, but I'm thinking that it won't change for the typical employee, the just employee class. So I'll leave this as virtual and have the base calculation for it. So now employee, what we can do is actually inherit from the base employee. And you won't need the first and last name. We won't need the salary. And we won't need the calculate per hour rate because that's the same as the base employee. Now we just have two extra methods, or a method and a property, because we also implement the I managed interface. And so you don't have an assign manager, which we do. Let's find out why. Here's why. Because it's an I employee, not employee. I employee and I employee. And now we can get rid of those extra ones it created for us. Always check your signatures. So there we go. So now that should work. We've just inherited from base employee, which brought in all the stuff that's common to all of us. But we also implemented the I managed interface. So now you can call this a I employee because base employee inherits from I employee. We can also call it base employee, or we can call it I managed employee. All right, now I'll show off how it's all working in just a minute. But let's go on to the manager, which inherits from employee, which we don't want anymore because employee has some extra stuff that doesn't necessarily work for us. But let's look at it. A employee has a manager and an assigned manager. Well, so does a manager. A manager has a manager and an assigned manager. So therefore, that's okay. So we can actually still inherit from employee, which inherits from base employee. And we also have this generate performance review, which is part of the I manager interface. So you have both now. Then the CEO, they are not an employee. They inherit from the base employee, but they're also the I managed manager, not managed. We take out this assigned manager. And now we comply with both base employee and also the I manager. Okay, so life should be good. Let's just build it, make sure we don't have any errors. And we do. Let's find out where that error is. Go to the error list. And that's back at our program because we said employee, a CEO is an employee. Well, they're not anymore. But we can say, you know what? A manager is. And that'll work. If we run it, Tim's salary is $27.75 an hour. If we change it back to an employee, that will also work. So now what we've done is we've changed our application over to be LSP compliant. We have reworked our interfaces, reworked our implementations, and our inheritance so that we can kind of mix and match these things, but at the same time, whatever we say we implement, we truly do in the correct manner. So a manager truly does implement the employee class, but it also has extra stuff, which is fine, and that's where the I manager comes into play. Whereas the CEO does not implement employee, it implements the base employee, because base employee is the one that has all of the stuff in common with everything. Now, one more thing before we go on, and that is we have this base employee class, but we never really want to use this directly. So therefore, it should be a public abstract class. Now, I don't want to go too deep into abstract class here, but essentially what this means is that this is a class you're going to inherit from, but you would never use directly. So we would inherit from base employee, but we'd never actually use it as a true employee. That'd be the more correct way of doing this. But the one thing it does do is it does limit a bit our example. So I'm going to leave this off for just a bit. I want to show you if we were allowed to use this, if this was something that made sense. Okay, so just having a first and last name, a salary, and the calculate per hour rate, if that made sense for a type of employee, then we come over here to our program CS, and maybe what we do is change this over to base employee. And of course, we can't assign a manager because all employees don't have managers. We could do the rest. And notice I'm actually assigning a new employee, not a base employee. But if we ran this, it would still work. If I were to change this over to base employee and run it, it would still work. If I changed it over to CEO, it would still work. And the reason why is because base employee is the parent class, both all of the above, employee, manager, and CEO classes. They all inherit from the base employee. And so therefore, these are all children of base employee. Therefore, they can be used in place of their parent, base employee, and not break or cause any unexpected functionality to happen. So no new exceptions, no tightening of preconditions, no loosening of postconditions, no covariance or contravariance issues. Essentially, it just means it doesn't break anything when you use it. And so that shows us that yes, in fact, we do have a correct implementation of LSP. So let's go back to employee. Before I do that, let's go ahead and over here and go back and put that abstract back in. And I just want to show you, this is the one thing that abstract will do for us, is if we have new base employee, it's going to go, no, you can't do that. Because we can't instantiate base employee. But notice if I had that employee here, no problem. Because it says, I know what LSP is and how it works. Therefore, any child class really is the base class item. So employee will work, so will CEO, so will manager, because I know that I can expect the same thing out of any of them. So that's how it all works. That's really the basics of LSP. Now, we can get into some more fun stuff here. For example, we could do the I managed here. And so we can have a manager, or we can have a CEO, and it should work just fine. Now, it's not. We're just saying object initialization can be simplified. Let's find out why. Rename manager to CEO. No, I don't want to do that. And then it's saying you can simplify. Nope. Oh, and I see that problem. So it's saying, hey, CEO is not an iManage, and that's because I made a mistake. And I meant to say manager, and that should now work. And in fact, it does. So I can also come over here and say, well, I want I managed for this person. And then come back over here and add the assign manager, because iManage has that. And that's it. I'm assigning a new employee to this. That also worked. So now I can kind of mix and match these things, and I know that if it's an iManaged, it's going to work the same way. So even if I have a manager here, well, a manager is an iManaged implementation. Therefore, again, it still works. The CEO is an iManager, as well as a manager is. Therefore, I can mix and match that as well, no problem. So you see how this gives us some flexibility here that we didn't have because we're correctly implementing LSP. We have that ability to swap out items for their parent class or parent implementation without fear that we're going to break something. Now, you did notice that the calculate per hour rate, yeah, that's different. The salary is, because a manager has a different salary calculation than a employee does or than a CEO does. And so there is some implementation issue you have to think through, but that's not what LSP is talking about. It's saying, no, the child class can go in place of the parent class and not break your application. Now, how you deal with the changes in those kind of values, that's kind of up to you. But that shows a true inheritance structure. Okay? So try us out, get to know it. But basically what this is designed to do is teach you how to write good inheritance. Because way too often you find that you start down this path of inheritance thinking, ooh, I can share code. And if the idea of sharing code is all you're about, then you're probably going to get it wrong. Because a lot of things share code. That doesn't mean they're related. My desk chair has wheels, and so does my car. Well, if you think about it, those two things both share an implementation. They both have wheels that turn. That doesn't mean they're related enough to have an inheritance structure. Just because two things have similar traits doesn't mean you have to have an inheritance structure. Instead, what you might have is you might have a shared method that's called, wheel turn. And it tells how a wheel turns. And maybe both the car class and the chair class use that method to demonstrate how a wheel turns or to actually turn the wheel. That's different. And that's where a different design pattern comes into play called dry. Don't repeat yourself. And if you find yourself doing repetitive code, my first instinct is to look at dry, not at inheritance. And when you start learning about inheritance, the first thing you see is everything inherits from everything else. Not really true. But there is a case for it. So for example, if you look at a Windows form project and you open up a Windows form, go to class, look at what the class form inherits from, and then follow that all the way down through. There's both interfaces and implementation of parent classes. And so there's both in play there. So there is definitely a huge case for this. It's just you have to do it right and figure out when is a CEO not an employee. In our case, a CEO is not an employee if the employee included the assigned manager and manager property. Because then a CEO doesn't really apply. It's not a CEO if they have those items. So just think this through, kind of digest it. Don't freak out. I mean, that's one of those things that when people look at this, they're like, oh my goodness, LSP is so complicated. And it's got so many rules. It's got so many names around it. But if you come back, think it through, it's just trying to help you create a good inheritance structure. Deal with it that way. Look it over. Make sure that you can pass these tests that it puts in place. If you can, you've probably got a good inheritance structure. So if you have any questions, I'd love to see them in the comments below. I'll try and answer as many as I can. If you want the source code for this, check out the description down below. And there'll be a link to my blog, which has the source code for both the start of this demo and also the end. Thanks for watching. And as always, I am Tim Corey.